All right, so welcome back. So 5.3, part B. And this part B won't take us very long. So we went through some of the ideas, the fundamental ideas of inverse functions, which is going to hopefully pay dividends, even though it's a recap from pre-calc. Hopefully it'll pay dividends into some of the places that we're going. So, but the idea, first let's make sure we understand the notation. So here f of x is your original function. And then normally we use this notation to represent the inverse of f. But, and I apologize, but I'm just kind of trying to mirror our textbook. Since what your authors are doing is they're going to just let this inverse be represented by g. Okay, so instead of writing f inverse traditionally the way we do, we're just going to henceforward write it as g. And that's just for this section, right? It has to be, if you see g of x in another chapter, another section, that doesn't mean it's an inverse. It's just for right now, henceforward for the rest of this section, g of x now denotes the inverse of f of x, okay? But look, here's just it's a fairly easy derivative that you can, derivative formula. I give it to you without proof. It's actually not that bad of a proof, but I have to pick and choose my battles, if you will. And it goes a little bit like this. So let's just say you have g, right? You have an inverse, and you want to find its derivative. Well, lo and behold, you can actually use the original function and as a means, and its derivative as a means of finding the derivative of an inverse. So this little formula, which I kind of made a little bigger down here, this is our formula for finding the derivative. Remember, g means inverse, right? So g prime would be the derivative of the inverse. So this is going to be our formula for finding the derivative of an inverse function. And let's take a look at it. So notice it's a quotient, so it's a 1 over what? So 1 over the derivative of f prime, of g of x. Now, this will make more sense in just a second when I do an example. Obviously, we do have an aside here, a disclaimer, clearly that f prime of g of x cannot equal 0, right? Because if you did, you would be dividing by 0. Okay, so I kind of parked that little formula up here on the top right, but let's jump into example 6. So it says let f equal x squared, okay, for all x greater than or equal to 0, and then let the inverse of f equal the square root of x. Now that makes sense, right? So how do you undo a square? Well, a square root. So these are inverses. Now, our job is to show that the slopes, right? So the slopes of the graphs of f and f inverse are reciprocals at each of the following points. Interesting. So let's see if we can unpack this question, right? So let's start with if we want to show, right? If we want to show that the slopes of the graphs of f and f inverse are reciprocals. Well, right now, at least in calculus, if somebody starts talking to you about instantaneous rates of change and slopes, I mean, look, in calculus class, when in doubt, think derivative, right? That's kind of our training. So let's go ahead and get some derivatives out of the way. So what is f prime of x? Now be careful with these notation, right? You gotta, this is an inverse. this is a prime symbol. So this is the derivative. So that's why, again, this is why your authors are using g, right? So g of x is the inverse. So, but let's go ahead. This is an easy derivative to take. So if you want to take the derivative of f, well, what is the derivative of x squared? Well, it's just 2x. Now the question is, how can we find the derivative of the inverse using this information, right? So let's go ahead and go right to our formula. So if you want to find the derivative, and obviously if we want slopes, we do want a derivative. So it's going to be 1 over f prime of g of x. So let me go ahead and write that. So 1 over f prime of g of x. Do I have g of x? Well, yes, I do. Do I have f prime? Yes, I do. So let's just go ahead and start putting all the pieces in the right spot. So this is going to be 1 over. So let's start with, so notice that this right here, this is just f prime, but you're inserting g of x in for x. So I'm going to go ahead and write it. So that's just going to be 2 square roots of x. Now I'm going to venture to say that there's at least a handful that just said, whoa, what just happened? Where did that come from? Do you agree with me that g of x is the square root of x? Do you agree with that? Okay. Do you agree with me that f prime is just 2x? Do you agree with that part? Then notice that this is just inserting g into the derivative for x, right? So here's g, and we are just inserting into the derivative. So that I just dragged and dropped. And that's where this 2 square roots of x comes from. Okay. So what information, what is here? What are we doing right now, right? What are we doing with our lives, if you will? So look, this is a function to give you slopes of f. And this is a function to give you slopes of g. So let's go back to the question. It says, show that the slopes of f and f inverse are reciprocals at each of the following points. So let's start with 2, 4, 4, 2. 2, 4, 4, 2. Well, so notice that x is the input, right? If you plug 2 into f, let's see what we get back out. So f prime of x is equal to 2x, and then g prime of x is equal to 1 over 2 square roots of x. So now, let me just say what's going to happen. What's going to happen is I'm going to plug a 2 in for f prime, and I'm going to plug 4 into g prime. And what you're going to see is that they are reciprocals. Right, so f prime of 2, g prime of 4. All right, so notice that this is a point. If you are lost, my apologies. This is just one of those sections that it's quite easy, but it's so easy it's hard, if you will. I'm doing my best. This is a point on this graph. This is a point on this graph. Okay? So if you plug this point, so we plug 2 in for f prime. Well, let's go ahead and do that. So f prime of 2, that would be 4. All right, now we go to that corresponding point on the g-graph, and now our input is 4. So if you plug 4 in for g prime, you get 1 over 2 times the square root of 4. Well, the square root of 4 is 2, so that's 1 over 2 times 2. Right, so 1/4. And now show that they are reciprocals at the following points. Well, these are reciprocals, right? These are reciprocals at the following points. I will skip part B. You could plug 3 in for f prime and then plug 9 in for g prime just to make sure that you're getting reciprocals, but it is true you will be. And lo and behold, that is all that I'm going to cover for 5.3. It's not a bad section, and at least I hope you agree with me. That's not a bad derivative to have to take, right? Fairly easy derivative. Okay, I will see you guys in the next section.